Hi everybody, welcome to a new Python tutorial. Today we're going to talk about decorators in Python. Decorators are a very powerful tool in Python and every advanced Python programmer should know it. In this video I show you the concept behind decorators, how you can write your own decorators, the difference between function and class decorators, and some typical use cases. I promise you that once you have understood the concept, it is not as difficult as it seems in the beginning and it might improve your Python knowledge a lot. So let's start. There are two different decorators, function decorators and class decorators. More common is the function decorator and it looks like this. So you have a function, call it def, and let's say call it do something, and it does nothing in this case. And above your function you have an @ sign and then some other function name, so some decorator function name, let's say my decorator. So this is how the decorator syntax looks. And what this does, a decorator is a function that takes another function as argument and extends the behavior of this function without explicitly modifying it. So in other words, it allows you to add new functionality to an existing function. So in this case, this function would be extended with the functionality of this decorator. And in order to understand this concept, we have to know that functions in Python are first-class objects. This means that like any other object, they can be defined inside another function, passed as an argument to another function, and even returned from other function. So now let's have a closer look at the concept. So let's say we have a function and call it print name, and this will simply print Alex. And then we have a decorator function, call it start and decorator. And now as an argument, it takes a function. And inside our decorator function, we have an inner function and we call it wrapper. So def wrapper, this is a wrapper function which wraps our function. So inside this wrapper function, we execute the function, and then, as I said, I can extend the behavior, so I can do something before and I can do something after it. So before I say, in this case, simply print start, and after it I want to print end. And then after creating this inner wrapper function, I also have to return it. And now to apply this, let's first of all let's execute the print name function. So now if I run this, it prints Alex. And in order to apply the decorator, I assign this print name function to our decorator function. And as argument, I take the print name function. So now the print name function has this new functionality. So now if I run this, we will see that it prints start, then executes the function and prints Alex, and then it prints end. And now the decorator function will do the same thing as this line. So now if I write @start and decorator, then I don't need this anymore. So this now does the same thing. If I execute it now, it will also print start, Alex, and end. And now this is how we can extend the behavior of a function with a decorator. So let's see what happens if our function has some arguments. So let's say we have a function, call it @5, and this takes an argument and then it returns x plus 5. And now if I try to run this, add 5, and as argument I give 10. Now if I run this, I will get a type error because our wrapper takes 0 positional arguments, but 1 was given. So here I need the same arguments as here, and to fix this I can use the args and quarks. I will talk about this in another video in more detail, but basically with this syntax I can use as many arguments and keyword arguments as I want. And now inside our wrapper function I also call this function with the arguments and keyword arguments. So let's write it like this. And now if I execute it, then it works. So this is how you apply arguments. And now what about the return value? So let's store this in a result. So let's say result equals add 5 and then print the result. Now if I print this, this will print none here. And to fix this, I also have to save the result of the function here and then return it from my inner wrapper function. So return result. And now if I run this, it can print the result. And now as a last thing, what about the function identity? So let's print the help function of add 5, the help information with this help function, and also let's print the name of this function with this double underscore method. Now if I run this, this will print that the help function wrapper and the function name is also wrapper. So Python got confused now about the identity of this function. So in order to fix this, I can import functools, and here before my wrapper I apply also a decorator. It's called functools.wraps_func. So this will now preserve the information of my used function. So now if I run this, I see that it now knows the help on function add 5, and also our function name is now again add 5. So this is all to complete the decorator syntax. So this now is a template for a decorator that you can use for all your function decorators. So let's say call it my decorator. Then you can do something before the function, then you execute the function, and then you can do something afterwards, and then you return the result and return the wrapper. So this is the template for a nice decorator. And you can also have a look at this on my website, python-engineer.com. Yeah, so now as we've seen here, we see here a decorator that takes a function, that takes an argument. So decorators can also take arguments, and what this means, this is basically now two inner functions, so an inner function within an inner function. And to make this clearer, we look at another example. So let's say we have a function, call it greet, and then it takes a name, and then inside it will print, and now we use an f string, and I've shown this before in another video about strings. So you can say hello, and then inside braces we use the name, and now we use a decorator and call it repeat and give it an argument num times and set it to 3. So I want a repeat decorator that executes this function 3 times. So how does this decorator now look? First of all, we have the outer function repeat, which also takes num times, and then inside it takes our decorator function as we've seen it before. So we have a decorator, so define a decorator repeat, and this takes a function, and then inside here we have our wrapper, and this takes arcs and quarks, and we decorate this with our functools.wraps decorator. And then inside our wrapper, I simply want to repeat this the number of times I've given here. So I say for underscore, because I don't need this, for underscore in range num times, and then I say result equals our function with the arcs and the quarks, and then I return the result, then I return the wrapper, and then I return the decorator. So now if I execute greet Alex, then this will be executed the number of times I've given here. So now if I say executed 4 times, so this is how the concept behind decorators with arguments work. And now let's also talk about nested decorators. So you can stack decorators on top of each other. So you can, let's say we have a function and call it, let me copy this here. So we have a function, say hello, which gets a name. Then it prints a greeting and returns the greeting. And now we can debug this. We can decorate this with our start end decorator as we've seen it before. Now let me copy this here inside. This is our start end decorator, which will print start and end after our function. And we also decorated this with a second decorator and call it debug. And now let me copy this debug decorator in here. So this debug decorator extracts the name and the arguments and the keyword arguments, and then it prints the information of this function. It executes the function, and then it also prints the information about the return value. So this will basically print some more information about this function. And so now if I apply multiple decorators to a function, they will be executed in the order they are listed. So this means now if I execute, say hello Alex, this will first of all execute the debug function, and then inside the debug function it will execute the start and decorator function, And then inside this function, it will execute the sayHello function. So now if I run this, we will see that first of all, it prints calling sayHello. This is from my debug wrapper. Then it prints start from the start end decorator. Then it prints hello Alex, then end, and then again I'm here. It prints the function name and the return value hello Alex. So this is how you can apply multiple decorators. And now as a last thing, let's talk about class decorators. So instead of a function decorator, you can also define a class decorator. So let's say we have our function sayHello, and then it simply prints hello, and I want to decorate this with a class decorator, and I call this count calls. So class decorators do the same thing as function decorators, but they are typically used if we want to maintain and update a state. So in this example, I want to keep track of how many times I have executed this function. So let's create a class, call it count calls, and this has a init method, and it takes self, of course, and then it takes the function, just like the decorator function. And then inside the init, I will save the function as class variable or as member variable, and I say self func equals func. And then I will also create a state, and I call this self.num calls. So, and this is 0 in the beginning. So I want to keep track of how many times this got executed. And now in order to write a class decorator, I have to implement the call method. So this also takes self, then the args and the quarks. And this is the same as the inner function in our function decorator. And now, sorry, this also has trailing double underscores. And now the call method allows me to execute a object of this class just like a function. So let's, as an example, let's just print hi there here. And now let's say I create a object of this class called cc equals count calls, and this takes a function here. So in this example I just use none. And now, since I've implemented this call method, I can say cc and execute this as a function. So now if I run this, it prints hi there. So in our example, I don't want to print hi there. So what I want to do now, I want to update the state. So I say self.numCalls plus equals 1. Then I want to print the number of calls. So I print this is executed self.numCalls times, and then now this is my, then I also have to execute and return the function. So I say return self.func, and now I call the function with all the arguments and the keyword arguments. And now if I say If I run this and I say hello, then sorry, self num calls. Now if I run this, then I will see this is executed 1 time, and now if I run this again, then I will see now this is executed 2 times. So here I can keep track of how many times this is executed. So this is how you can implement class decorators. And now let's talk about some typical use cases of decorators. So for example, you can implement a timer decorator to calculate the execution time of a function. You can use a debug decorator like you've seen before to print out some more information about the called function and its arguments. You can use a check decorator to check if the arguments fulfill some requirements and adapt the behavior accordingly. You can register functions like plugins with decorators. You can cache the return values, or you can add information or update the state. So that's all about working with decorators. I hope you enjoyed this tutorial and now feel comfortable working with them. And see you in the next tutorial where we talk about generators in Python.